This video will present the mechanism for distributing tasks and roles among agents. In order to simulate this distribution, we developed a graphic interface, which can be applied in PANGEA, that lets us see how to carry out a distribution. We will use a planning agent and a distributor agent. The planning agent is responsible for designing the global plan that the organization will carry out. The planner generates a plan that can establish the number of agents with their respective specialization or roles that must exist in the organization in order to carry out the tasks. It also assigns each task to a specific agent so that the global plan can run as efficiently as possible. Replanning occurs when the entry queue includes a specific number of unassigned tasks, 5% of the tasks in the previous queue, or when the established plan can no longer be carried out. In order to carry out the planning process, the agent follows the CBR-VDI planning model. The number of agents that should be available in the system is estimated dynamically. The idea is for the number of agents to adjust to demand while ensuring that the utilization factor remains less than 1. The estimate is made using queuing theory. Once we have established the number of agents that will be initiated to minimize costs, the tasks are assigned among the available agents. This is done with a genetic algorithm. Once the planning agent has generated the plan, the distributor agent makes sure that all the members of the organization adapt to it. In order to do this, each time an agent finishes an assigned task, the distributor provides it with a new one. It also makes sure that the task has been completed within the established time frame for the plan. Otherwise, it will notify the planning agent so that it can replan accordingly. The following information is required for each task. ID task identifies the global task which is represented in the same way through the system. Type task identifies the specific activity that must be performed. Profit refers to the total return from executing the task for the specific case. This field is important when determining the number of agents needed to minimize costs and not increase losses that may result from certain tasks not being carried out. Accumulated profit is the value that may be lost as a result of previously done work. It is associated with the total accumulated benefits from the steps previously taken for the same task. The entry date contains information about the date when the task was originally received. This field is important for determining the receive date of a specific type of activity for a specific date. Deadline refers to the maximum time needed for resolution. This value is established for each type of task. Duration is the time used to perform a task. We will now review the main functionalities of this tool. Data loading is an essential step that must be taken before any simulation, since without data, it is impossible to have a simulation. That's why we have a Load Data button on the menu bar in the simulation item, and a shortcut button, Control-C, that loads data for the tasks that are waiting to be executed. The initial data are rescued from an XML file that contains the tasks, task ID, type of task, and entry date. After the data loading process is complete, the queuing theory calculations are made. This step essentially consists of calculating the number of agents needed to execute the tasks that are in the queue. The number of agents calculated will provide the greatest possible return for the job. Because queuing theory calculations require past information on the agents, we access the database CBR model. We can obtain information such as the average rate of arrival or of service, which is critical for these calculations. We will obtain the rest of the information required for the simulation when the simulation is initiated using the genetic algorithm calculations. When the data has been loaded, a task queue will appear identifying each task with its task ID. Once the task data has been loaded, the next step is to begin the simulation. There is an Initiate Simulation button inside the simulation item and a shortcut button in the toolbar. We can click on the simulation button although there are some details that should be pointed out. The different shortcut keys are Initiate Simulation, Control-S, Pause Simulation, Control-P, and Finish Simulation, Control-F. First of all, there is an internal step which involves calculating the genetic algorithms and distributing the tasks among the various agents calculated in the queuing theory. Once this has been completed, we obtain the planning and the completed task distribution, which means that the simulation can begin. We can see the task queue in the application. Also, at the bottom of the application, we can see images of the agent that will carry out the tasks. Each agent is assigned a color, shown on the left with the colored circle. The task queue is also colored so that each task corresponds to the color of the agent that will execute it, which is the agent that has been assigned in the planning stage. The agents vary according to the type of task they specialize in, according to the role. Once the agent receives the task, it begins to carry it out, and then continues with the next task that it has been assigned. As the tasks from the queue are executed, the queue gets smaller. When tasks are first added, they do not have an assigned agent to execute them, since the planning took place before the tasks were put in the queue. That's why an agent is not assigned until the replanning process has taken place. The color of those tasks will be orange, which means no agent. In order to randomly add tasks, you must click on the Add New Task Randomly button, which is found in the Add New Task item in Simulation, or by pressing Ctrl-N. The values of the tasks are random, which means that the type of task, the profit, the accumulated profit, and the deadline are completely random values. The program adjusts accordingly if necessary. It is also possible to add tasks with values provided by the user by pressing Ctrl-M. The following values can be input: type of task, profit, accumulated profit, and deadline. The timetables are a record or history of the list of times in which the tasks are executed, or of other information regarding the agents and/or tasks. If we want to display information from both tables, we have to press the shortcut button from the toolbar. The icon is similar to a clock, and both tables will appear on screen. This button and the buttons specified for each table are deactivated while the simulation is not operating, that is, prior to initiating it. This is because it makes no sense to display the tables if the simulation has not begun and there is no information to show. In order to access the agent timetables, you must either press the Agent button followed by the Display Timetables item in the Simulation menu, or Ctrl-G. This table displays information about the simulation agents. The information is available once the simulation has begun, and any significant changes will be noted in execution time in the same table so that this information is available to the user. The information provided is Agent ID, average execution time, number of tasks executed per agent, shown in green. In order to access the task timetables, you must press the Tasks button followed by Display Timetables in the Simulation menu. This table displays information about the simulation tasks that have been executed. The information is available once the simulation has begun, and any significant changes will be noted in execution time in the same table so that this information is available to the user. The information provided is Task ID, Assigned Agent, the one that executes it, Entry Date in Task Queue, Deadline, the time by which it needed to finish, and Actual Finish Time, shown in green. The user can configure some customized options before or during the simulation. The options are relative to the tasks. If you click on Configure Options in the Simulation item, a dialog box will open up. The user can configure the following options. The time between arrival of new tasks is a whole value that must be introduced in seconds and will vary the time that will pass between the arrival of one new task in the queue and the next, without counting the tasks that the user can add either randomly or manually. The default value is 5, which means that 5 seconds will pass between the arrival of one task and another. The number of tasks that can be added at a time must be an integer. It reflects the number of tasks that are added every certain amount of time, specified in the previous parameter, or whenever the user wants. The default is one task at a time. The number of new tasks before replanning is another integer and refers to the number of tasks that can be added to the queue without requiring a replanning process. The default is 5, which means that until there are 5 tasks in the queue with no assigned agent, there will be no replanning, so long as the plan times are carried out accordingly. Otherwise, it will be necessary to replan. The tasks can take a while to execute. This happens when the agents are busy with another task. The task will be displayed over the agent, which indicates it is being executed. Some tasks take longer than others to execute. It depends in large part on the type of agent and the average time required. If they want to, the user can experiment with what might happen if time were increased in the middle of the execution. To do this, the user clicks on any of the agents and inputs a value in the text box that appears. This value will be the delay in the task. If necessary, the replanning will take place, since it could be possible that the delay would affect the original plan and the deadlines would not be met. During the execution of the simulation, it is possible to use the IRC client or the monitoring tool to see how the agents work. In this case, if we open the IRC client and connect to PANGEA with the nickname Agent 8, this agent automatically enters the organization called distribution. The aim of this organization is to show how the distribution of tasks works. In the list of members, we can see the distributor agent who is permanently working, and other agents that enter and leave the organization if they have tasks to do. The planning agent is also entering and leaving the organization continuously, but it plans so quickly that we have no time to see it. However, we can observe that each time the planner enters, it writes a message in the channel.